Hello and welcome you all in the video lectures series on 8051 microcontroller. So in today's this video lecture we are going to talk about a basic registers which are present in 8051 microcontroller. Now before going to start this, let us have a quick discussion about the general types of these registers. Okay, so for sake of simplicity we are going to discuss it out here. So the first of all, here the various registers are present in 8051 microcontroller, and depending upon their use, these are basically or broadly called as a general purpose, okay, or the second one is simple SFR, that is this special, then second function, and then we are there with simple this registers. Okay, so no doubt in case of 8051 microcontroller we are there with different what we call the registers, and broadly depending upon this use, these registers are divided or generally said as a general purpose register or the special function register. So what is the basic use of this general purpose register? Okay, so these are the registers which are used to support the general purpose operations, and this operation may be like some arithmetic operations, okay, or some logical operations, or basically to say hold a data which is coming from different ports here. So these are what the general task that done by the microcontroller, and in order to support the general task, whatever the registers are used, these registers are called as a general purpose registers. Whereas the special function register, what is the special function registers? These are purely used to configure or support the operations of different internal block. Which are these blocks? The internal blocks which are present in a 8051 microcontroller there, right? So these are basically used to support or to configure the operations of internal blocks. Now which are these internal blocks? So basically the basic difference, so simple from here, the general purpose registers are those which are used to support the general operations like arithmetic operation, logical operation, or the data which is coming from the port to hold this data and for this purpose. Whereas the SFR, that is special function registers, are those which are used to configure or support the operation of internal blocks here. And the major differentiable point that exists, the SFRs are not used to support this or to perform the general purpose operations. If you want to do the arithmetic operation using SFR, no, it is not allowed. If you want to do the logical operations using SFR, it is not allowed. Fine. So for what purpose these are used? These are purely used to perform the or to configure the operation or associated with this internal block here. For example, when we talk about the internal blocks of 8051 microcontroller, we had discussed, we are having this, that is timer, then serial communication, then simple this interrupt control blocks. Okay, so when we discuss the internal architecture of 8051 microcontroller, these are the different blocks are there. So associated to support this timer operation, we are having one register, that is TMOD register, timer mode control register, or the TCON register, that is timer control register. Fine. So these are the basically called as a SFR, special function register. These two registers are purely used to support the operation of this timer block. Similarly, I am there with this as a serial communication. To support the serial communication, we are there with this SCON register or the SBUF register. You can't use this SCON register, TCON or TMOD to perform the arithmetic or logical operations. Why? Because these are the special function registers, and these are designed to support the operation for the internal block. So Here the Timon resistors are used to support the timer. Here the Ticon also used to deal with this interrupt control block. And to deal with this, we are there with the interrupt enable, that is IE, or interrupt priority, that is IP registers here. So these are the SFRs which are present in case of 8051 microcontroller. Okay, so these are not used to perform the general purpose operations like addition, subtraction, arithmetic or logical operations. These are purely designed in order to support only the operation of internal blocks here, or to configure the internal blocks here. So in today's lecture we are going to discuss these general purpose resistors which are purely used to support the general purpose operation that say supported by 8051 microcontroller. Okay, so basically the first and most important resistor is an accumulator, and then this accumulator is denoted as A. The memory location 0E0H, that is E0H, is termed as accumulator and it is denoted as A. It is simply an 8-bit register, which is a general purpose one, means we can use this register to perform the arithmetic and logical operations, and it's the most important register because it is used to accumulate the result that generated after the execution of large number of instructions. For example, say this arithmetic instructions. Okay, so basically means what exactly it says. Suppose right now I am going to perform the addition of two numbers. My first number is suppose this is the 05 and the second number is a 04, and when I am going to perform this addition, no doubt the result is my 09. So when I am going to deal with this addition, that is the arithmetic operation, my one number should be there into accumulator and the second number may be there into any general purpose register. However, whatever the result, it may be like say for addition I am going to get the result as 09, for subtraction I am going to get the result like say 01. Okay, so whatever that result that generated when I am dealing with this arithmetic operation in addition 9, in subtraction 01, after execution by default the result is present or it is stored into accumulator, that is into a register. So in this way, whenever we are going to perform any operation, right, any arithmetic operation, in that case the final ultimate result which is generated is by default stored into accumulator, and that's why it said that this accumulator is used to accumulate the result which is generated after execution of large number of instructions. Okay, so as said, it is used to hold the data as well as a result for temporary purpose. You can store any data for temporary purpose, or by default the result is get say accumulated into this accumulator. And the most important one, it is not a bit accessible register, right? So no doubt accumulator is an 8-bit register. Whenever you are going to perform any instruction, whenever you are going to send any data or going to retrieve any data associated with an accumulator, right, in that case we have to deal with all 8 bits of this accumulator. It's not like that I can utilize only one specific bit, say I am going to update the status of only the first bit or the second bit. It's not possible. Why? Because the accumulator is not an bit accessible register. So in simple, when we are going to deal with, okay, basically in case of microcontroller, later on again we are going to discuss to perform the multiplication operation, the one instruction is present and that instruction is called as a MUN. Okay, and for a division operation the second instruction is there and that instruction is called as a DIP, right? Basically when we are going to perform these operations in 8085 for multiplication, we will go with the successive addition method or add and shift method to perform this multiplication process, whereas for the division we are dealing with a successive, say this subtraction method, right? But in case of 8051 microcontroller, to support this multiplication and division, directly the MUL and DIV instructions are present, right? And while performing this multiplication, whatever the, okay, fine, so for this multiplication we are going to deal with say n1 multiplied with n2, no doubt. So this n1 and n2, these are the two numbers out of which the first number should be present, right, into this accumulator while performing the multiplication process. Okay, and while division process, whatever the dividend value is there, that dividend value is should be there always into an accumulator. So in this way, the accumulator is the most important register present in in case of 8051 microcontroller. It's mainly used to accumulate the result. We can store the data as well as a result for temporary purpose. It's an 8-bit register which is not an bit accessible register. The second register is a B register and its address is a 0F0H. As like microcontroller, say as like accumulator in microcontroller, it is also an 8-bit register, and it is again going to support a general purpose operations like addition, subtraction, multiplication, division. That is, say the arithmetic operations used to hold the 8-bit value. It is also not an bit accessible register. Whenever you are going to put any data into this B register, all the 8 bits we have to access from this B register. While performing the multiplication, the second number should be there into B register. Like this. Here we said, say n1 multiplied with n2. This operation we are going to do. So as per the rule, the first number should be there into accumulator and the second number should be there into B register. So in short, the syntax for this multiplication instruction is mul space AB. So mul AB. Whereas the A is going to hold the first number and the B is going to hold the second number. And both these numbers are what? Mainly 8-bit numbers, as the capacity of both A and B is a 8-bit byte here. Fine. So while performing multiplication, first number should be there into accumulator, second number should be there into B register. And while performing the division, right, the divisor is should be present into B register. For example, suppose now I want to do this n1 divided by n2. So as per rule, what should be there? The number n1 should be there into accumulator and the number n2 should be there into B register. For example, suppose I want to do this operation 4 multiplied by 2. So the 4 should be there into accumulator, B should be there into B register. And if I am dealing with the division operation, that is 4 divided by 2, then the 4 should be there into accumulator and 2 again should be there into B register in this way, right? So whatever the divisor is there, this divisor should be present into B register, right? So let us see how these A and B registers are used to support the multiplication and division operation. So as said, when I am dealing with this multiplication process, the mul AB, this instruction is there. The mul stands for multiplication, and to perform the division, the fixed syntax is there, that is div AB, that is divide content of A with content of B. Okay. So before execution, suppose the A is equal to 15 and B is equal to 12. So these two are the hex numbers. Now I am going to perform the multiplication of these two numbers here. So simple, pay attention here. My first number is 15. So 15 multiplied with say 12, right? And the obtained result is what? 17A, right? So in case of 8051 microcontroller, no doubt we are going to multiply these two 8-bit numbers, that is 15 and 12. However, whatever the result is generated, that result is a 16-bit result. So here whatever generated result is a 17A. So it is considered as a 017A in this way. So after execution, so the result is 017A, that is the total 16-bit value. So before execution, the first number is there into accumulator, second number is there into B register. But when I am going to perform the multiplication of these two 8-bit numbers using A and B register, the generated result is a 16-bit while, and it is stored in a such a way that the lower 8 bits of your result are stored into accumulator and higher 8 bits of the result are stored into B register. So in this way, the execution will take place. Suppose I am going to perform this, that is say 4 multiplied by 2. No doubt the result is what? Right now it's a 8. But in microcontroller it is treated as 0008, right? And the content of accumulator will be 08, that is lower for 8 bits, and the contents of B register will be 00 after execution of instruction. Similarly, to perform this division operation, suppose A is equal to 05 and B is equal to 02. So when I am going to perform this division operation, no doubt I am going to get the remainder as a 1 and the quotient value as a 2 here. Fine. So after execution, the result which is generated, the quotient value is a 02H and the remainder value is a 01. So this The A is going to hold the quotient value, that is 0 2, and the remainder is gets stored into B register. So in this way, the multiplication and division, these two operations are supported by this A and B register, okay, which are present in a case of 8051 microcontroller. Now the next, that is the most important one, is a general purpose resistors, which are say Rn, that is R0 to R7. So these are an 8-bit resistors, generally termed as a general purpose resistor, used to hold the 8-bit value. These are present into resistor bank. These are also not an 8-bit resistors and used as auxiliary resistors in many operations. For example, if you want to perform the addition of two numbers, the one number is there into accumulator and the second number may be present into any register which is from R0 to R7. Now the most important thing that we have to take into consideration, okay, so before that, when we are dealing with an internal memory, then the register R0 and R1, no doubt I am total there with the 8 register which are going to say indicated from R0 to R7, that is R0, R1, R2, R3, R4, R5, R6 and R7. No doubt in this way total 8 registers are with me, but out of these 8 registers only R0 and R1 registers are used as a internal memory pointer. Fine, okay. So now just pay attention towards the second statement, that is present in register bank. So when we had a discussion about the memory architecture of 8051 microcontroller, right? So in that we have seen, no doubt, and there will total 128 byte of memory. Okay, so suppose this is the total 128 byte of memory which is there with me. So which is going to start from 002, going to end at 7H. Now when I'm going to talk about the first 32 bytes, so these first 32 bytes are divided as say the register banks here, that is from 00 to 07, 08 to 0F, 10 to 17, then 18 to simple is 1F, right? So in this way total these 32 bytes are kept aside as a register bank, okay, like this. So what it indicates, we are there with register bank 0, as we had already discussed, bank 1, bank 2 and bank 3, and we have seen in each of this bank we are having a different registers which are termed as a R0 to R7. That when I am going to talk about a register bank 0, right? So as indicated here, the register bank 0 is going to start from 00 and going to end at 07, means total I am there with this 00 first location, 01 second location, 02 third location, 03 fourth, 04 fifth, 05 sixth, 067 and this 078. In this way the total 8 again these slots are there when I am going to talk about the register bank 0. Similarly when I am dealing with bank 1, again I am there with the 8 slot. So each of this slot is denoted as R0, R1, R2 up to this R7, means total 8 registers. As shown here, fine. So when I am talking about this register bank R0, then R0 to R7, these registers are there. So memory location 00H is termed as a R0. Similarly, when I am dealing with the bank 1, which is going to start from 08 to 0F, the location 08 is again termed as what register R0. Then 09 is with R1, R2 in this way. So in this way, total say this 32 general purpose registers are there with me, which are termed as a Rn. So when I am going to talk about register R0, total 1, 2, 3, 4, 4 R0 registers are with me. When I am talking about simple R1 register, then again 4 different R1 registers are with me. And in order to switch from one bank to another bank, once SFR is there, that is program status word, that we are going to discuss later on. So with the help of that, we can switch from one register to one register bank to another register bank. So in this way, these are the different Rn registers are present, and these registers are present into each of the bank, that is bank 0, bank 1, bank 2 and bank 3. Okay. So the next is a DPTR. It is known as a data pointer. So when we compare the data pointer with that of the rest of earlier discussed register, the basic difference is that the data pointer is a 16-bit register, and it is used as a memory pointer to point out an external memory. So we know that as per the requirement, we can interface an external memory to 8051 microcontroller. So when I am dealing with this external memory, to point out this memory location, we are going to make use of this data pointer. So what the data pointer is going to do, which is denoted as a DPTR file programming, this data pointer is going to point out the 16-bit address of external memory, as it is what the 16-bit register. So this 16-bit DPTR can be used as a 8-bit register, DPH dealing with the higher 8 bits of DPTR, and DPL the lower 8 bits of DPTR. So as indicated here, no doubt this DPTR is a 16-bit register. So lower 8 bits are termed as a DPL and higher 8 bits are termed as a DPH. Now consider this. Suppose I am there with this one memory map, right? So this memory, for sake of simplicity, consists of two columns. The one column is going to deal with the address of this specific slot, and the second column is going to hold the data. So this is my first slot, second slot, third slot, fourth slot, in this way. If I consider this as my 64 KB memory, then the first memory location is with the address 000H, and the last memory location is with the address FFFFH here. Okay. So suppose right now I want to copy this data, that is 9F, which is present at memory location whose address is 6589. So what we are supposed to do, first of all, we have to point out this memory location, and this task is now done by whom? Your DPTR. So what the DPTR will do, the DPTR is now going to hold this specific address. That means the content of DPTR are 1001, that is 9, 0001, that is 8, 01015, and 0110, that is 6. So in this way, the content of DPTR are 6589, out of which the DPL is going to hold the 89, that is the lower 8 bits, and the DPH is going to say hold the higher 8 bits here. So in this way, we can access an external memory with the help of this data pointer. The next register is a program counter. Okay, so before going to understand the program counter, let us consider this memory map, right? So here I have stored my code from, suppose, the memory location 6589 onwards. So 6589 holds the data 9F, the 6590 holds the data 47. So basically the program counter is also an 16-bit register, as like your DPTR, but it is helpful to continue the flow of execution of your program. And the most important thing about program counter is that the program counter is always point the address of memory location from where the next instruction is to be fetched and executed. Okay, for example, suppose right now the CPU is dealing with a data 9F, which is present at 6589, and after that it is going to deal with this 6590 memory location, no doubt. So during execution of instruction which is stored at location 6589, the program counter is going to point out the next memory location, right? Means what? Suppose right now the CPU is dealing with an this address 6589. No doubt the CPU is dealing with 6589 memory location address, but the content of program counter is a 6590. Why? Because after this 6589, the CPU is going to deal with the next address, that is 6590. So in this way, the program counter is always going to point out a memory location from where we are going to fetch and execute an next instruction. So these are the some important registers which are present in case of 8051 microcontroller. Now another one is there. So that register in case of 8051, that is called as a SP. The SP stands for stack pointer. Okay. So as per the property of 8051 microcontroller, it is mainly an 8-bit register, whereas in case of this is for what? 80, sorry. The stack pointer is basically an 8-bit register in case of 8051 microcontroller, whereas in case of 8085 this is a 16-bit register. Okay, in case of microcontroller, as we are dealing with a microcontroller, now we are going to consider only this. And once we reset the device, by default the content of stack pointer is what? 07H. So what is there? Basically the stack is a reserve part of memory which is used to hold the data for temporary purpose, and to point out this stack memory, basically this stack pointer is used. So after this discussion, in the next video lecture we are going to discuss about the stack and stack memory. In that, this stack pointer we are going to discuss in detail. Only remember, the stack pointer is the 8-bit register, and this always point out a stack memory. In case of 8051 microcontroller, whenever we are going to send any data into stack memory, okay, suppose I am there with this I'm there with this as my stack memory, right? So inside the stack memory, whenever we are going to put the data, the content of stack pointer are get incremented by 1. First the content of stack pointer get incremented by 1, and then the result is stored. And when we are going to retrieve a data, that I will say the output operation, the content of stack pointer are get decremented by 1. So this is the most important thing that happen in case of 8051 microcontroller. Okay. So these are the basic registers which are used for the programming purpose in case of 8051 microcontroller. And whatever the SFRs are there, that is special function registers, right? So these special function registers we are going to discuss when we are dealing with an individual block there. For example, when we are going to talk about a timer section, then the different bits of TMOD register, TCON register we are going to discuss. When we are dealing with the serial communication, the use of SCON and SBUF register, and during interrupt control block, the use of interrupt enable and interrupt pivot registers that we are going to discuss here. Okay, thank you.